Welcome back to this introductory lecture on set theory. In this third segment, instead of giving you new definitions, I'm going to give you practice problems so that you can get familiar with all of the definitions we discussed in the previous two segments. So for these practice problems, let's consider three specific sets that I chose randomly. Assume that S1 is the set containing the empty set, the integer 1, the integer 2, the singleton set 3, and the integer 4 and integer 5. Let's take S2 to be the set containing the integers 0, 1, 2, and 3, and the set containing the singleton set 4 and the integer 5. Finally, let S3 be the set containing the integer 1, the letter B, and the word dog. Now, I'm going to put up a bunch of questions. I'm just going to read through them. Then I'll ask you to pause the video to answer the questions, and then we'll come back to discuss the answers. So the first question is it true that the cardinality of S1 is equal to the cardinality of S2? In fact, is it true that S1 is equal to S2? For the third question, is the empty set an element of S1? And is the empty set an element of S2? The fourth problem asks you to determine whether the empty set is a proper subset of S1 and whether the empty set is a proper subset of S2. Next, is 1 an element of the power set of 3? Is 1 a proper subset of the power set of 3, of S3? Is the singleton set 1 an element of the power set of S3? Is the singleton set 1 a proper subset of the power set of S3? Is the singleton set containing the singleton set 1 a proper subset of the power set of S3? And finally, what is the power set of S3? At this point, I want you to stop the video and to answer each and every one of these questions to the best of your ability. And in the process, make sure you review all the definitions and you're very methodical in your application of these definitions to these problems. And I'm sure you can solve most of these, if not all of these, on the first trial, as long as you understand the definitions. So this is a good test of how well you understood the definitions from the two previous segments. So welcome back. Let's discuss the answers to these 10 problems. So for problem number 1, the way to find the answer and to justify it is to simply determine the cardinality of the sets S1 and S2. How many elements does the set S1 contain? 6. So its cardinality is 6. Now, how many elements does the set S2 contain? That's a little bit more tricky, but if you look at it carefully, you'll notice it contains 4 integers, 0, 1, 2, and 3. That's 4 elements, and then just one extra element, which is this set. In other words, the cardinality of S2 is 5. 6 is different from 5. So the answer to the first problem is definitely no. So the only tricky thing here I wanted to point out is that, for example, the number 5 is not an element of S2. 5 is an element of this set here with 2 elements, which in turn is an element of S2. But 5 is not an element of S2, neither is 4, and that answers this question. Let's turn our attention to question 2. Are the two sets S1 and S2 equal? Well, the answer to the first problem gives us the answer to this one. If the two sets don't have the same cardinality, they can't be the same sets. Remember, to be the same sets, you must contain exactly the same elements, and in particular, you must have the same cardinality. Now, if you didn't answer the first question, you could still look at the sets and see that they are not the same. For example, the first set does not contain the integer 0, whereas the second one does. So that's one difference right there. That's enough. Another difference is that the first set contains the empty set, the second one doesn't. That's a second difference. A third difference is that the second set contains the integer 3, but instead the first set contains the singleton containing the integer 3. These are two different elements, and so on and so forth. So sets S1 and S2 are different, definitely not equal. Now to problem 3. Is the empty set an element or a member of S1? The answer is yes. It appears right here. Is the empty set an element of S2? The answer is no. The empty set appears nowhere here in the list of the elements of S2. Is the empty set a proper subset of S1? Well, the answer is yes, because the empty set is a proper subset of every set except the empty set. Remember, we're talking about the proper subset here, not just the subset. So as a result, the empty set is also a proper subset of S2, since S2 is not empty. Okay, so now let's turn our attention to the power set of S3. And the tricky part here is about this concept is you should be able to answer these questions here even before you've actually written up the power set of S3 itself. So let's try to do that. Of course, another way to go through these problems would be to answer this question first, list all the elements of the power set of S3, and then go back and answer these. You could do it that way, that's fine. Let's try to do it in order. So, is 1 an element of the power set of S3? And right away you can answer no to that question. Why is that? That's right. If you go back to the definition, you'll see that the power set of S3 is a set of sets. So the only elements in a power set have to be a set. Since 1 is not a set, there's no way that 1 could ever be an element of the power set of S3. You see, you can answer this question without actually building the power set of S3. Now, is 1 a strict subset of the power set of S3? Again, the answer is obvious. To be a subset or a proper subset, you must first be a set, and 1 is not a set. So I don't care what you put on the right-hand side here, but 1 is not a proper subset of anything. So the answer is no. Now let's consider problem number 7. Is the singleton set 1 a member of the power set of S3? So now it's a little bit more interesting because the answer could be yes, since the left-hand side of the set membership here relationship is indeed a set. But is this set indeed an element of P of S3? Well, let's think about this. What are the elements of the power set of S3? It's all the subsets of S3. So what this is asking is the singleton set 1 a subset of S3? If the answer is yes, then the answer to this problem is yes. So let's look at S3. Is the set containing 1 a subset of S3? And the answer is yes, since 1 appears here. Therefore, the answer to problem 7 is yes. So again, the way to check this answer here is to realize that the set containing 1 is indeed a subset of S3. How do you check that? Well, you take all the elements of this set and you make sure they also belong to S3. Here there's only one element, the number 1. 1 is also in S3. Therefore, this is indeed a subset of S3, and therefore by definition it's an element of the power set of S3. Now in contrast, let's look at problem 8, which asks, is the same singleton set 1 a proper subset of the power set of S3? Now, if the answer to that question is true, that means every element in this set should be an element of the power set of S3. And what are the elements of this set? Well, there's only one, it's the number 1. So is 1 an element of the power set of S3? And the answer is no. We already answered this question right here. So since 1 is not an element of the power set of S3, the set of 1 made up of 1 is not a subset of the power set of S3. So the answer here is no. See, as I told you, the concept of a power set gets a little tricky, especially when you have sets of sets and so on. So make sure you agree with all these answers and that you understand how we got to them. So to answer the question number 9, you just have to go back to the definition of being a proper subset. Namely, is it true that every element of this set on the left-hand side is also an element of the set on the right-hand side? Well, there's only one element in this set, namely it's the singleton set 1. So the question we're asking here is this singleton set 1 an element of the power set of S3? And the answer is yes. That was problem number 7. So that's the first half of the answer. Remember, we just proved that this set is a subset of this one, since all the elements of this set are also in this one. But to be a proper subset, you must make sure that this set right here is also different from the power set of S3. And here it's pretty clear it is different, because the power set of S3 is going to contain a lot more than one element. Notice S3 already has 3 elements, so its power set is going to be even bigger. In conclusion, we just proved that this set is indeed a subset of the power set of S3, and it's not the same as the power set of S3, so it's a proper subset. Now finally, I'm asking you to compute the power set of S3. So let's do that. Now remember, the power set of S3 is a set, and it contains, by definition, all of the subsets of S3. So how many subsets are we going to have? Well, you could use the formula we came up with earlier and realize that the power set of S3 is going to have 2 to the 3 equals 8 elements, because S3 contains 3 elements. Now the question here is, how do you find them? That's the answer to this question. Well, let's list them in order from smallest in terms of cardinality to largest. Obviously, the empty set is going to be a subset of S3, so it will be the first one listed. Then we're going to consider all the singleton sets, namely the set containing 1, the set containing B, and the set containing dog. That's another 3 elements. And then we're going to consider the set with 2 elements, namely 1 and B, 1 and dog, and B and dog. That gives us another 3 elements right here. And finally, don't forget, S3 is a subset of itself, and it will be the last element in the power set of S3. Notice I wrote the name S3 here instead of copying the whole set, but that's the same thing. So in conclusion, we just computed the power set of S3, and now we can use that information to go ahead and check some of the previous answers. So let's do that before we wrap up this segment. We already know that the answer to these 2 questions is no without looking at the power set, because 1 in this case is not a set, and 1 in this case is also not a set. So let's focus on problems 7 through 9. Is 1, the singleton set 1, an element of P of S3? The answer is yes, because it's right here. So it's an element. This element is inside P of S3, so it's an element of the power set of S3. Therefore, the answer should be yes. Is the same element a subset of P of S3? The answer is no, because 1 is not, the integer 1 is not an element of P of S3, so the set containing 1 is not a subset of the power set of S3. On the other hand, because this is an element of the power set of S3, when you put it into a set, it is indeed a subset of the power set of S3, and in fact it's a proper subset since this set is different from that set. So I think this set of practice problems will be very helpful to you until you can solve those in a comfortable manner and pretty fast. I'd say you're not comfortable enough with the definitions we've seen so far. So please practice those as much as it takes and make up your own examples, and let me know if you have questions.